since the unit circle is so important for us, I want to have you get really good at filling this out and knowing the values on these things. So let's do this. Let's start out with this rational expression, square root of 4 over 2. And then next to it, I'll write square root of 3 over 2. Square root of 2 over 2. Can anyone fill in the next one? What do I write next? What's the next term in this sequence? Square root of 1 over 2. Can anyone go one more? What will be the next one? I've got the 1, 0. Now, 3 of these will actually simplify. So let's simplify them. The first one is 1. The second one doesn't simplify, so that's just square root of 3 over 2. The third one is square root of 2 over 2. How about this one? Does that simplify at all? Yeah, it's just 1/2. How about the last one? It's 0. Now, why do I care about these 5 numbers? These 5 numbers are going to get a lot of work done for us here. And let me show you where those come into play. Now, what we're looking at here is what's called the unit circle. I mentioned that in section 2.1. The equation for that is x squared plus y squared equals 1. And it's the points on this circle that are going to be very, very helpful in terms of you figuring out certain trigonometric ratios. So let's understand some of the points on this circle. First of all, this is 0 degrees. And 0 degrees, the x-coordinate is going to be a 1. The next one you might remember is 30 degrees. And the x-coordinate here is going to be square root of 3 over 2. The next one up from that is going to be 45 degrees. Any guess as to what the x-coordinate there is going to be? Square root of 2 over 2. Thank you, sir. And then the next one after that is 60 degrees. Some more guesses. What coordinate should I put in here for the x-coordinate at 60 degrees? 1/2. Thank you. And finally, up here at 90 degrees, you got an x-coordinate of 0. Yay! Well, what about the y-coordinates? Well, guess what? Let's take these and run them back down. This is going to be a 1. This is going to be square root of 3 over 2, square root of 2 over 2, 1/2, and 0. Yay! So you've got the coordinates of your points in the first quadrant. Now there is a little bit more that we're going to add to this graph. For instance, this is 0 radians. In terms of radians, this is pi over 6. This is pi over 4. This is pi over 3. Does anyone remember what a 90-degree angle was? Somebody gave that to me earlier today. Pi over 2. Now, I color-coded this so that you can kind of see things a little bit easier. These angles are different by 90 degrees. So if this is a 30-degree angle, what's this one over here? 120. So that's 120. We calculated that one earlier in radians. That's going to be 2 pi over 3. And now I need to figure out the coordinates. Well, I'm done with this pattern here. I only use it for the first quadrant. Over here, I'm at the same y height. So the y height is going to be square root of 3 over 2. But what about the x-coordinate? The x-coordinate is not going to be a positive 1/2. What's the x-coordinate going to be? Yeah, the opposite, negative 1/2. Nice. And so once you have things in the first quadrant, you can figure things out everywhere. Now, if you start out with 45 and you add 90, you'll have 135 degrees. That's 3 pi over 4. And you can figure out the x-coordinates there. Let me jump down to the third quadrant. let's take this angle and reflect it all the way down to here. So I'll help you out here. Let's see, that's going to be 210 plus another 30 degrees. It's going to be 240 degrees down here. 240 degrees is going to be 4 pi over 3. But what I want you to understand is how you're going to get the points on that one. Now, if I move straight down from here all the way down to here, am I changing the x-coordinate at all? No. You're just changing the y, so the x-coordinate is still the same. It's still going to be negative 1/2, and you're right, the y-coordinate is going to become negative. So all you're doing is you're jumping down from here down to here, and you're making the y-coordinate negative. In fact, let's take that point one more time, and this time I'm going to reflect it across the y-axis over to here. That would be an angle of 300 degrees, which I'll save you the conversion. That's going to be 5 pi over 3. And now what are the coordinates going to be? Well, there's two ways you can get it. You can change the x-coordinate. When you move across the y-axis, the x-coordinate is going to go from negative to positive. And then the y-coordinate, well, you're still at the same y heights. It's going to be negative square root of 3 over 2. What's another way I could have gotten that one had I wanted to? Had I could have figured out the coordinates at that point?
Could you use the coordinates from the first quadrant?
Yeah, thank you, Nico. So, yeah, you could have done from the first quadrant. You could have said, okay, well, I can go down from 60 degrees all the way down to here, and the x-coordinate is going to be the same, but the y-coordinate is going to be opposite. Notice that instead of going positive 60 degrees, you're essentially going negative 60 degrees. Negative 60 degrees is going to be the same thing as a positive 300. So in this way, you can get all the coordinates and angles and radians that you need by working around the unit circle. So I strongly suggest that we take a moment and try and fill out the rest of this. And you can work together, you can work alone. If you finish alone, then compare yours to a neighbor. But try and figure out the rest of these coordinates and at least some of the angles in radians. Now, I'll help you out maybe with a few of these in degrees. You should know this one. That's going to be 180 degrees, which is going to be pi radians. And that's going to have coordinates of negative 1 and 0. Down here at the bottom, this is going to be 3 pi over 2, which is your 270 degree angle. Anyone for the coordinates on this one? 0, negative 1. Awesome. Awesome. And just see what you can do for the rest of these. So we'll circle back in a couple minutes and see if you can't fill in these the rest of the way. There's probably going to be a quiz on this earlier or later this semester. Just a chance to give you some easy points. I want you to have this memorized. It's going to be a no calculators quiz, timed. Just get it done. But you're going to have all the answers. You know exactly what the quiz is going to be. It's going to be the same paper that I'm handing out to you now, just blank. All right. Try and get the points on the unit circle, the angles and radians. If you can catch some of those, that's great. You should be able to do the conversions if you had to. one got it done. No? All right.
No, I know it's not.
Oh, okay.
I just wrote the pies on there.
Oh, I see.
I'm gonna put the number in front of it. once we
Okay,
get done.
all right, that's cool.
Yep.
Clever.
Oh, thank you. I guess. Oh, did I write the wrong number here? Oh, 270.
Yeah, 3:30. Yeah, that's
That's okay. Yeah, I mean, I don't expect people to know the radians getting that fast. I do hope that you can get the points. Okay. Okay, so knowledge about the radians comes a little bit slower than, understanding these points on the unit circle. I hope that by reflecting things, that you can get all of these points. I mean, that's what I really hope. Yes?
The one under the zero under the first quadrant and the second quadrant, the empty spot, is that 360 and
So, yeah,
2 pi?
so you can do this as 360 and 2 pi.
Okay.
So that's another name for that same angle, right?
Yeah.
So that's kind of interesting. A lot of these angles, in fact, every single angle here has more than one name. I could think of this as being a positive 330 degrees or a negative 30 degrees. Or I could think of it as negative 390 degrees. So once around and then negative 30 degrees after that. So each of these angles actually has an infinite number of names. Now, when it comes down to the angles and figuring out radians, we can take, say, 330 degrees times pi over 180. And you can see that angles of, or the units of degrees is going to cancel each other out. 30 goes into both of these, goes into the numerator 11 times, and in the denominator 6 times. So 11 pi over 6. But there's your points. And, you know, I just can't emphasize enough how helpful it is to really know your unit circle. And that's why I took time to show you how to derive it. It's because, I mean, yeah, I've got this kind of memorized from teaching this for so many years, but for you, I'm really hoping that this pattern here, figuring out the first quadrant, once you get the first quadrant, the rest of that stuff follows. You can get whatever you want. Now what I'll do on your test is I'll give you a blank unit circle. You can fill it out or not as you want, all right? But they're really, really handy to know very well. Comments or questions? Yes?
Is this going to be available on D2L to like print off and like practice on?
Yes, actually it is available on D2L. Yes. So, good question. Anything else?
Did you make a paper now? Thank you.
You're welcome. You're welcome. Okay. Now, the reason we did this is because it's going to lead into what we're going to do next, and that's define some trigonometric functions.